Here is an explanation for the answer to final exam, question number 50 in Alternative Energy Demystified, 2nd edition. If you have the printed book, please see page 320. We're talking here about the Earth ionosphere supercapacitor. It is constantly being recharged by renewable energy sources. Well, those sources generally include the sun and cosmic radiation. Those are the two primary sources. The key word here is renewable. Renewable. Energy from the sun is just about as renewable as you can get. But cosmic rays from space are even more renewable in the sense that the Earth will still be bombarded by cosmic rays from space even long after the sun has died, assuming that the sun doesn't gobble up the Earth first in its red giant phase, but that would be a topic for another book. The correct answer here is C. The Earth ionosphere supercapacitor is constantly recharged by renewable energy sources including cosmic rays from space. Well, let's look at the Earth ionosphere supercapacitor. What do we mean exactly by that? Well, there is an ionized layer in the Earth's atmosphere, actually several ionized layers, the lowest of which occurs at an altitude of about 50 kilometers. It's called the D layer, and it is most active while the sun is up. So on the day side of the Earth is when you will find the most intense ionization at this lowest level. There are other layers called the E layer and the F layer at roughly 80 kilometers and 300 kilometers respectively. They can also ionize at night, and those layers are more likely to be the subject of cosmic rays from space when the sun is down. The D layer, the main source is the sun, but the cosmic rays still, of course, arrive at the Earth. These, even during the daytime, you'll get cosmic rays. You get them all over the Earth all the time. Well, these cosmic particles and solar particles cause the upper atmosphere of the Earth to ionize, and that means that the atoms become electrically charged, and as a result, between this ionized layer and the Earth itself, you get a constant potential difference on the order of hundreds of thousands of volts, about 250,000 to 500,000 volts DC to be exact, and that is what is responsible ultimately for lightning discharges. When you get a thunderstorm, an intense rainstorm, a thunderstorm, sometimes a volcano, a sandstorm, any major atmospheric disturbance can increase the likelihood that a discharge will occur in that particular location where the disturbance occurs, and then you get this spark, and it actually jumps all the way from the ionosphere to the Earth. You just don't see it all. You only really see the part between the cloud and the ground, but they have observed the discharges above thunderstorms, especially in Wyoming. They go out there for that specific purpose, to watch these big thunderstorms as they roll in at night across the Thunder Basin National Grassland. Where do you suppose it got that name from? Anyway, they watch these little discharges occur above the tops of the thunderclouds all the way up into the upper atmosphere, and they call those little flashes sprites and jets. But anyway, the cosmic rays and rays from the sun are primarily responsible for this electrostatic charge. So once again, the correct choice for this question is choice C, cosmic rays from space.